Hey guys, so here are your notes for fundamental identities. I decided to do it like I did before, not using the computer this time since I was having so much trouble last time. And I decided to do it on YouTube because I can do it all in one video instead of a bunch of different segments. So let me know if you prefer this or if you prefer it in segments. I don't know. I feel like this is easier. It's easier for me, for sure. But anyways, we'll see. Okay, so fundamental identities. This is our topic for today. So we're going to learn about some identities that we need to know. Okay. And it says an equation that is true is what goes in that blank for all values of the variables in the expression. That's what an identity is, a fundamental identity. Okay, so this next part is the identities. So let's go over them. We have our basic identities. They are the reciprocals, like sine and cosecant, cosecant and sine, cosine and secant, secant and cosine, tangent, cotangent, cotangent and tangent. Okay, those ones we already know. And I'm going to give you a hint for these reciprocal functions. The hint is that reciprocals don't start with the same letter. Oops, I spelled with wrong. With the same letter. So if you've been one of those students that's had trouble remembering which ones go together, is it sine and cosecant or sine and secant? Well, sine and cosecant don't start with the same letter, just like cosine and secant don't start with the same letter. So just remember, it's always SC, CS, okay? They never start with the same letter, and that's how you can know. All right, so these ones we already know. We already know these. So that's what's nice. So there's nothing new about there. Like, we didn't know that those were called identities until now. Well, I did, but you guys didn't. But, okay, so now let's also recall that we have these ratios, tangent and cotangent, which we also already knew these as well. Tangent is sine over cosine, cotangent is cosine over sine, excuse me. So we need to know those two. What's new are the Pythagorean identities. So when you hear Pythagorean, you should be thinking of one special little formula or theorem. Pythagorean theorems, a squared plus b squared equals c squared. The Pythagorean identity here in trig is very similar. It has a lot to do with the Pythagorean theorem. And the big kahuna is sine squared x plus cosine squared x equals 1. As long as you remember just this one, you have it down, okay? So when we use an identity, we use it so we can replace other things, so we can simplify an expression or an equation. So when we do that, just remember, it doesn't always have to look exactly like this. We could rearrange it. So say I needed the sine squared x by itself. That means I would have to subtract cosine squared x from both sides. So on the other side, I would have 1 minus cosine squared x. So there's a variation of it. Say I wanted cosine squared x by itself. Then I would have to subtract sine squared x from both sides, and I would get cosine squared x equals 1 minus sine squared x. Okay, so there's another variation of it. You don't have to memorize these because we can rearrange them all day long. You should be able to recognize relationships once you see them, once you see something that looks similar to this, and I'll show you what I mean by that. The other two identities we can get by first dividing this whole thing, the big kahuna, by sine squared x, and then dividing the whole thing by cosine squared x. So I'm going to go to a separate sheet of paper for that. Where is my separate sheet of paper? Here it is. So sine squared x plus cosine squared x equals 1. So I'm first going to divide everything by sine squared x. That's what it said. And this is how I'm going to derive the next identity. So sine squared divided by sine squared is 1. Cosine squared over sine squared, hey, remember? Cosine over sine is cotangent. So since it's cosine squared over sine squared, this is a cotangent squared of x equals 1 over sine squared. Hey, that's a basic identity. 1 over sine is cosecant, so 1 over sine squared x would be cosecant squared x. So there is our second identity. Okay, to find the third one, you take the big kahuna again, sine squared x plus cosine squared x equals 1. And we have to divide everything now by cosine squared x. So they're taking turns. Okay, so sine over cosine, that's a basic identity. Sine over cosine is tangent, so sine squared over cosine squared would be tangent squared of x, plus cosine squared over cosine squared is 1, and 1 over cosine squared, well, 1 over cosine is secant, so 1 over cosine squared x would be secant squared x. And there is our third identity. So these are the 3 big identities that you guys are going to be dealing with. Okay, so if we go back to the notes page, okay, I can go back and highlight these. So there's identity number 2. So this is the big kahuna. This is number 2, and this one is number 3. And of course, we can rearrange all of these. Okay. All right, so how are we going to use these? Well, you're about to find out. Turn the page. If you're not able to get these printed at home, hopefully you are copying these down ahead of time before the video. If not, you can always press pause, copy it down real quick, and then fill in the notes as we go. Okay. All right, here's our first example. We're going to use the exact values to verify each identity for the given value of theta. Okay, so first of all, we're going to use our unit circle. So for number 1, sine squared of theta plus cosine squared of theta equals 1. Basically, we need to figure out, well, where is this located? Okay, so we know that theta is pi over 4. So if I draw a little graph, and I have a unit circle on this graph, pi over 4 is the 45-degree angle. And the coordinate of that is square root of 2 over 2, square root of 2 over 2. So cosine and sine are both square root of 2 over 2. Okay, so let's input that angle. So that means I would have sine of pi over 4 squared plus cosine of pi over 4 squared. Is that going to equal 1? I'm verifying that this is true. It said to verify. So we're verifying it. Okay. Well, sine of pi over 4, well, the sine is the y value. It is square root of 2 over 2. So I'm going to replace the sine of pi over 4 with square root of 2 over 2. Plus cosine of pi over 4 is the same exact thing. Okay. So I'm going to square this. When we square a fraction, we square the numerator and the denominator. The square root of 2 squared, well, the 2 gets to come out because we squared a radical. And 2 to the second power is 4, so I have 2/4 plus, well, this one's the same thing, so it's also going to be 2/4. 2/4 plus 2/4 is 4/4, which equals 1. Hey, it equals 1. Check. It's verified. Okay. All right, number 2, we're going to verify that one. So we have the sine of negative theta equals negative sine theta. And we have theta is 30 degrees. Okay, so let's replace the theta with 30. So I'm going to have sine of negative 30. Is it really going to equal negative sine 30? Well, we're verifying it, so that means it is true. So we just have to prove that it's true. So let's go back to our graph, put in a unit circle. Okay, 30 degrees is over here, pi over 6. And we know the coordinate would be square root of 3 over 2, comma 1/2, cosine and sine. Negative 30 degrees is down here, clockwise from the starting position. And it's the same as 11 pi over 6, in case you didn't know. And the x value is square root of 3 over 2. The sine is negative 1/2. We have to use both because a negative 30 degrees is not the same as a positive 30 degrees. They have the same coordinates, but they have different signs for their sine value, their y value. Okay, so let's input this. What is the sine of negative 30 degrees? Well, sine is the y value, and that y value is negative 1/2. Okay, negative, what's sine of positive 30 degrees? Well, positive 1/2. Oh, but there's a negative out front. A negative 1/2 equals negative 1/2, so check. Verified. It really does work. Okay, so those are verified. So this kind of goes to show you that these do work and we can use them to prove things. And it kind of tells us that a negative inside with the angle is equivalent to a negative outside the sine of an angle or cosine of an angle or tangent of an angle. So that's kind of good to know. All right, so what are we going to do? The next part is we are going to simplify the following expressions. So how are we going to simplify things? I'll draw a little arrow here. We are going to simplify by substituting out so things cancel. So we're going to substitute out so things cancel. That's supposed to be a little squiggly. Okay, so that is what we are going to do to simplify these expressions. I like these a lot. I feel like they're like a puzzle. You just have to solve the puzzle, simplify it, get it to be so minimal that you're like, yes, I did it. And I don't know, you might like these, you might hate them, but at least try them out, okay? So we have sine of theta, cosecant of theta. So sine of theta, I could replace with something, but cosecant of theta is catching my eye because cosecant is equivalent to 1 over sine. And I want stuff to cancel out. And I know that I can cancel something out if I switch cosecant to be 1 over sine. So that's exactly what I'm going to do. Sine of theta, and then I'm replacing cosecant with 1 over sine theta. Hey, sines cancel. And so all that's left is a 1. Okay. Now, I totally could have replaced sine with 1 over cosecant, and the cosecants would have canceled, and I still would have gotten 1. So there are different ways to do these. So don't think that there is only one correct way, because there is not. There are multiple ways to do a lot of these problems. So the way that you might think of it may not be necessarily the same way that I think of it or one of your friends, okay? All right, next one. Number 2, secant squared theta minus tangent squared theta. Okay, first of all, I see secant and tangent squared, and I'm like, well, is that any of the identities? I have a secant and tangent squared in here. Let's see. Secant minus tangent squared is, it's already rearranged right here. It equals 1. Oh, so I already know what it equals. It's going to equal 1. So I know it equals 1. Or if you didn't notice that right away, you can use the basic identities and you'll still get 1. So let me show you another way that's a little bit harder than this one if you don't remember the identity. Remember, secant is what? 1 over cosine. So let's replace secant squared with 1 over cosine squared theta. Minus tangent squared is, tangent is sine over cosine. So let's replace tangent squared with sine squared theta over cosine squared theta. We have fractions, and that's okay. We have common denominators already. We have common denominators anyway. Haha, I should have rhymed. Be Dr. Seuss. Okay, so this would be 1 minus sine squared theta over cosine squared theta. And 1 minus sine squared theta should look familiar. It should look highly familiar to our big kahuna. So I'm looking for 1 minus sine squared. Hey, we rearranged it there. There it is. 1 minus sine squared is equivalent to cosine squared of x. So I can replace 1 minus sine squared with cosine squared. So this equals cosine squared theta over cosine squared theta. Well, when you divide something by itself, it equals 1. So we just showed 2 ways to do this problem, and to distinguish between the 2 ways, I'm going to highlight the or so we can see that there were 2 ways that went that way. Okay, we used an identity right from the bat, or we can go about it a little bit longer route. We still end up using an identity, the big kahuna one, rearranged, and we still get the same answer. So there literally is different ways to do these problems, so don't think that you are limited to only one way. Okay. All right, number 3, sine squared theta over secant squared theta minus 1. Okay, well, this one looks familiar. Okay, so I'm going to go back to my sheet. Secant squared theta minus 1. Theta, x, they're just representing an angle, so it doesn't matter what it is. So let's see, if I rearrange this and get secant squared x minus 1, that means I would have to subtract 1 from both sides. So that means that tangent squared x would equal secant squared x minus 1. So what I could do is I can replace the secant squared x minus 1 with tangent squared x. So I'm going to do the replacement. So sine squared theta over tangent squared theta. Okay, now I know that I can replace tangent with something. So I would have sine squared theta over tangent is the same as sine over cosine. So that would be sine squared theta over cosine squared theta. You're probably thinking, whoa, Ms. Garcia, there's a double fraction bar going on there. What the heck? It's okay, don't freak out. So I'm just gonna write sine squared theta, because that's the numerator. And then I'm gonna use this second fraction bar and change it to the divide symbol. So divided by this fraction, which is sine squared theta over cosine squared theta. And dividing fractions, that's easy as pie. You flip the second and multiply. So I will get sine squared theta times cosine squared theta over sine squared theta. And guess what? Sines cancel. So all that's left is cosine squared theta. And that's the answer. Okay. Number 4, we're going to simplify in terms of cosine. Okay. So What does that mean? That means that we're gonna keep it in terms of cosine, okay? So I'm gonna put this over 1 because I have a fraction here. And in order to add fractions, we have to get what, guys? If you said common denominator to your phone or computer, you're right. So this is a cosine theta, this is a 1, so I need them both to be cosine theta. So I need to multiply top and bottom by cosine theta. So I'm going to have sine squared theta plus cosine times cosine, so cosine squared theta, because cosine times cosine is cosine squared. All over, they have a common denominator now of cosine theta. Well. Sine squared plus cosine squared equals 1. So this numerator then equals 1. So 1 over cosine theta is the answer. Or if you prefer, 1 over cosine is the same as secant. So you could even put secant of theta. It works also. It did say to simplify in terms of cosine though, so technically this is the ultimate correct answer, but these are the same thing. So if you didn't put that, I wouldn't dock you for it because technically you're right. So there you go. All right, that's number 4. And that is it. So here is your homework. You have numbers 1 through 8. And so what I want you guys to do is do all these problems. Please make sure that you show your work and then upload pics of this into Google Classroom. If you're using your phone, like the iPhone, like definitely use the Notes app. It turns it into a PDF and it does it in color and it makes things so clear and easy for me to see. Some of you guys have been uploading pictures and they're sideways or upside down. That's really difficult to grade. So please be mindful of that. If it's sideways when you upload it, then can you change the orientation of it so that it's upright when I'm looking at it? And if the lighting is really crappy, can you turn on a light or find the sun somewhere and take a better picture? Because I need to be able to see what you put in order to give you a valid grade. All right, if you have an Android phone, I'm sure there's a free app that you can download to scan your homework and turn it into a PDF. There's got to be something. If anyone knows something for Android, please share that with the class or email me and I'll share it with everyone. So please let me know so that we can help each other out. Because yeah, we need to figure out how to do that properly and in the best way, most efficient way, you know, all the above, especially if we're going to be doing this for a while. All right, guys, have a good one. I'll see you in my next video.